All right, class. This is Mr. Eggleston, and this is lesson 9.5 for Algebra 2, angles on the coordinate plane. This is like the third attempt I've had of recording this because I've been screwing up or getting interrupted. So here we go. We're going to learn how to draw angles in standard position and what that means, okay? It's not that hard. It's actually pretty straightforward. So we'll define what standard position is, and we'll go from there. We're going to find coterminal angles. That's new language. Coterminal angles basically share the terminal side of the angle, and you're going to learn what a terminal side is. Basically, it's the angle that's given, and you're going to add or subtract 360 degrees to it, because 360 degrees is one full revolution around the circle. Then we're going to learn how to calculate a reference angle for an angle in standard position, which is the angle between the x-axis, the acute angle between the x-axis, and the terminal side of the angle. And then after all that, we're going to find how to calculate trigonometric ratios for angles in standard position. So here we go. So basically, that's an angle in standard position. You start. The initial side is the side that is pointing along the positive x-axis, and then you measure the terminal side moves in the counterclockwise direction, and this is the terminal side, and together that forms an angle. That's standard position. You have your initial side and you have your terminal side. Coterminal angles are angles that share this side. So if you imagine going around the circle once, you're back at the same angle. Here, you're sharing the terminal side of the angle. Those are coterminal, and the angle difference is 360. So you basically add or subtract 360 degrees. All right, so basically you need to understand that angles are measured positive when it's moving in the counterclockwise. So the angle is positive in that direction. The angle is negative if you move in the clockwise direction. We call that the negative direction. All right? So this is all referencing this Mrs. Gaius wants to make algebra fun. The antithesis of what I do. I like to make it boring and mind-numbing. And as Shawl here can attest to.
What?
You can attest to that I make algebra really boring.
Oh, really?
Oh, she's not playing along.
Oh, yes, Mr. Eggleston is very boring.
Okay, there you go. This is going to be saved for posterity's sake. If you're in my Algebra 2 class in a couple of years here, you'll probably hear your voice on this if you watch this video at the end of the year. Okay, so back to this. So anyway, she's trying to make algebra fun by having a spinner where you can win prizes. Okay, so you kind of need to see the spinner. Well, this is the spinner right there. All right, and you basically are going to start your spinner. Will start right here. And we're going to spin it in that direction, counterclockwise. Now, Tara really wants to win lunch with Ms. Gaius. What is the smallest number of degrees she can spin in order to win? That is, she wants to win lunch with Mrs. Gaius. She has to get into this region right here. So to spin the smallest number of degrees, the terminal side would have to end here. Okay. So this angle there is the smallest angle. So they wanted you to sketch it on the little axis here. So we're going to draw a little line like that. Okay. Now, to help you figure this out, you have to remember that perpendicular lines like the x and y axis form a 90-degree angle. So basically you have 1, 2, 3 sectors added together give you 90. Now you're assuming, of course, that each sector, each of these little regions, right here, this region, that region, all have the same angle. They all share the same angle. That is this angle there. Those are all the same. So to figure that out, you have a total of 90 degrees, and that's split up between 3 of these angles, which is 3x, where x is the unknown angle that we're looking for. So x equals 30 degrees. So each of these angles, each of these regions right here. Why does it keep doing that? There it goes. Is 30 degrees. Okay? So you figure you got to go through 1, 2, 3, 4, 5 sets of 30 to get to this point here. So that would be the answer. So it's this angle, and that angle is 150 degrees. It is 30 added together 5 times. 30 times 5. Okay? All right. Now, we don't need the spinner to look at the spinner to answer the next one. Tara actually spun 510 degrees. Did she win lunch with Mrs. Gaius? Sketch the angle on the axis. So, I gotta shrink my pen down. And the way you would do this is 510. So this is 0 degrees. That's 90. 180. 270. If we go back around, that's 360. Notice I'm just adding 90 each time. 450. 450 plus 90 is 540. 540 plus 90 is 630. And so forth. All right. And then we'd be 630 plus 90, it would be 720. So Tara actually spun 510 degrees. So if you think about this, we will go around, that's 360, 450, 510 would be somewhere in here. So that's 510 degrees. And the question is, did you end up in the same position as to win the prize? So we want to know if this was originally 150. The easiest way to do this is to take the angle you spun, 510, and then start subtracting 360 from it. That's 1 revolution. So 510 minus 360, using my handy dandy calculator, because it's early in the morning and I don't trust my brain, is 150. So that is the same angle that you need to win, because now that purple angle is the 150. So theta equals 150 degrees, and yes, she won. Okay. We call 150 and 510 coterminal angles. Okay. These are coterminal angles. Oh, come on. Anyway, coterminal angles are angles that are the original angle plus or minus 360. So 510 equals 360 plus the original 150. Okay. So, because that's 150 degrees. So 360 plus 150 is 510, and 150 is the angle we needed. So it's a coterminal angle. 510 and 150 are coterminal. If you land on the start line, you get an extra spin. Jacoby spun 170 degrees. How many degrees was he from getting an extra spin? So let's figure this out. We got 0, 90, 180. You win if you land on the x-axis. He spun 170, which would put you right there, where this is 170 degrees. And they're asking you, how many degrees was he from getting an extra spin, which means how far away from the x-axis is he, which is that. That angle is 180 minus 170, which equals 10 degrees. Okay, 10 degrees is called the reference angle. It's the angle that is the closest angle between the terminal side and the x-axis. So 10 degrees is the reference angle. Okay, so it was the full 180 to get to the straight angle to get to the other side of the x-axis, minus the 170, which is what he spun, and that difference is 10 degrees. Okay, so we refer to those as reference angles. Reference angle is the distance from the x-axis. Okay, you're going to be always trying to figure out what the reference angles are when you get into higher level math. We won't get into it here. We'll just see the next lesson will be the unit circle, and that'll be it. So, and you'll just get to see it and know that it's out there. Okay, Ali was 70 degrees away from winning an extra spin. That means he is 70 degrees away from the x-axis, either over here or over here. How many degrees could he have spun? Give at least two possibilities. Well, one would be if he lands here, where that's 70 degrees. Also, you could have landed here, where that's 70 degrees. You could have landed here, where that's basically 7 degrees. And you could have landed here. So this is 70, this is 70. So you can land in any of those quadrants. Remember, this is the first quadrant. It's important to know what quadrant you're in. That's first, that's second, that's third, and this is the fourth. So if he's 70 degrees away, he could have spun, well, 70 degrees, which would put you in the first quadrant right here. Right? You could have spun it right there. But you could also have spun it and landed over here. That's 70 degrees. So that's going to be 180 minus 70. So that's going to be 180 minus 70 is 110 degrees. Okay. You could also have landed here, which is 180 plus 70. So that would be 180 plus the 70. And that is, what is that? That's 250. You could also have landed over here, which is 360 minus 70. So you could have gone 360 minus 70, which is, I believe, 290 degrees. So, those are all possible winning. And then, of course, you can keep adding 360 to each of these numbers and get other, if you spin multiple times around. Those are all possibilities of the angles that he could have given. Obviously, just knowing that you're 70 degrees away from the x-axis is not enough information to give you a precise answer. All right. Now, that's all about coterminal angles and moving things. So now Reed broke the rules and spun clockwise and landed in the exact same spot. Okay, so Reed spun 35 degrees. So, but he spun it clockwise, which means this is 35 degrees clockwise, right? Now, Nick followed the rules and landed in the exact same spot. So Nick has a coterminal angle, which would be there also. And let me make that dash so you can see that they're on top of each other. Okay. So Nick followed the rules because Nasad is a good rule follower and spun it that way. All right. Again, Reed didn't follow the rules, so he spun in the opposite direction. What is the smallest number of degrees that Nick could have spun? Nick is the blue. So if this distance, if this is 35, so this is going to be 360 minus 35. So we would have to go 360, that's the full circle, minus the 35, which was in the wrong direction. And so Reed, or not Reed, the other guy, Nick, would be 360 minus 35, which is 325. So this blue angle is 325 degrees. All right? Now, you have both angles. You have to know this clockwise spin that Reed did because he broke the rule. This is going to this is clockwise. Theta is negative. So that should be negative 35 degrees, not positive. It's negative. And then Nick spun a theta that is positive because he went in the right direction, the positive direction. So it's a positive 325 degrees. Okay? So all this leads to this thing that you have to know. That is, angle measured clockwise equals negative degrees. Counterclockwise is positive. That's the sign convention. Okay? So, when